All right, Ph261 Chapter 7 homework problem number 3. The figure below shows 3 forces applied to a trunk that moves leftward by 4.2 meters over a frictionless floor. The force magnitudes are F1 equals 5 newtons, F2 equals 6 newtons, and F3 equals 3 newtons. The indicated angle theta equals 60 degrees. Now, just like before, let's start out by listing our givens. We're given we have F1, F2, and F3, and those are 5, 6, and 3 newtons. We also know theta equals 60 degrees. And we know that displacement is equal to 4.2 meter. And I'm just going to say negative 4.2 because it's leftward for no other reason. And I know it's displacement because it says the block is moved leftward. So if the block is here, it's going to get pushed this way, and its new position is here. And this would be 4.2 meters. Okay, now with this, we can look at a free body diagram, and let's look at what each force is in fact doing. Now we have force 1, which is just in this direction, and then force 2, which can be broken up into a x and y component, and then F3, which again is just in a singular direction. So we only have to worry about angle theta for F2, because it is the only one that is at, well, really any sort of angle. So let's see. We can do, for just the x direction, so let's do F net x is going to be equal to the force 1 minus F2, and now we're going to have to make sure this is cosine theta, and then we're going to have F net y, which is going to be equal to F3 minus F2 sine theta. Okay, from here we can calculate what this is. This is going to be 5 minus 6 sine 60, and then, or my apologies, cosine. And then this one is going to be 3 minus 6 sine 60. Okay, now, what do these equal? Oh boy, when did I start erasing? Cosine 60. Let's plug it in. 5 minus 6 cosine 60 is going to be equal to 2. And 3 minus 6. What did I do here? Did I make that cosine? My apologies. Sine 60. 2. 60, and then this one is actually negative 2.19. All right. Now it's asking us, during the displacement, what is the net work done on the trunk by the three forces? Well, we can do is, since it's work, and work equals the force times displacement, what this is going to be is, since there is no actual displacement for F net y, since the block is just moving along one axis, it is not moving up or down, it is just moving left and right. What this means is the only work done on this object is in the x direction. So from here, we're going to take this, which is the F net of x. I'm going to do F net of x times displacement of 4.2, or F dot d, and that should give us work x, which is the only work this object has, and that is equal to 8.4. Now, that's part A. Part B asks, during the displacement, does the kinetic energy of the trunk increase or decrease? Now, kinetic energy is the energy that an object has in motion. And during the displacement, motion occurs. So I could say that it increases. Potential energy would be like more of the amount of energy an object has to move, or has the ability to move, whereas kinetic would be the actual motion. So for part B, the answer is increases. All right, and that is that problem.